Imagine the night sky, a vast dark canvas scattered with stars. Among them, could there be another world like ours? For centuries this was pure speculation. But now, with powerful telescopes, we're finding planets orbiting distant suns. Sometimes we discover a world that truly stands out, a world that hints at the possibility of life. One such world is closer than you might think, LHS 1140b, a super-Earth in our cosmic neighborhood. This isn't science fiction, it's real, a planet bigger than Earth, orbiting its star in a way that suggests it could have liquid water. Water, the essential ingredient for life as we know it. LHS 1140b isn't just another data point, it's one of our best chances yet to answer the question, are we alone? Our cosmic backyard is far more interesting than we ever imagined. We've found gas giants hotter than furnaces, diamond worlds, and planets where it might rain glass. But it's the super-Earths, familiar yet alien, that truly excite us. So, let's embark on a journey of imagination, guided by science, to explore what makes LHS 1140b so special. We'll examine the evidence, weigh the possibilities, and confront the challenges of knowing for sure. This is more than an astronomical curiosity, it's a quest to understand our place in the universe. The story of LHS 1140b is a chapter in our ongoing search for life beyond Earth. Before we dive deeper, what is a super-Earth? It's a type of exoplanet, more massive than Earth but lighter than Neptune or Uranus. Super-Earths aren't small and rocky like Mars, nor are they gas giants. There's something in between, a class of planet missing from our own solar system. These worlds have changed our understanding of planet formation. In fact, super-Earths might be the most common planets in the Milky Way. Each one we find is a precious laboratory. Some are rocky, like scaled-up Earths. Others are mini Neptunes with thick atmospheres. Their size and mass help them hold on to atmospheres, protecting surfaces from radiation and cosmic rays. But it's a delicate balance, too massive, and they become inhospitable gas worlds. Too small, and they lose their atmospheres. Super-Earths exist in that Goldilocks zone of planetary mass, large enough to be geologically active, but not so large as to be uninhabitable. That's why finding a super-Earth in the right place is so exciting. Now let's meet LHS 1140b, one of the most promising super-Earths ever discovered. Found in 2017, it orbits a red dwarf star, LHS 1140, just 49 light-years away in the constellation Cetus. That's practically next door in galactic terms. Red dwarfs are small, cool, and dim, so their habitable zones are much closer in. LHS 1140b orbits its star every 25 days. Close enough for warmth, but not too hot. From Earth, we see the planet transit its star, blocking a tiny bit of starlight. These transits let us study the planet's atmosphere as starlight passes through it. Because of this alignment and its proximity, LHS 1140b is a prime candidate for atmospheric study. It's likely a robust rocky world that's held onto its atmosphere for billions of years. Its host star is unusually quiet for a red dwarf, reducing the risk of sterilizing flares. The combination of size, location, transits, and a calm star makes LHS 1140b a dream target for astronomers. It's almost as if this world was tailor-made for us to study. LHS 1140b stands out as a beacon in our search for life. Let's see what makes it so alluring. What makes LHS 1140b so remarkable? Its size and density tell us it's a rocky world, not a gas giant. With a diameter 1.7 times Earth's and nearly 7 times the mass, it's dense, likely with a large iron core. This suggests geological activity, which is vital for recycling elements and maintaining a stable climate. Geological activity means a dynamic, evolving environment, key for life. LHS 1140b receives about half the sunlight Earth does, but a thick atmosphere could trap enough heat for liquid water. If its atmosphere is rich in greenhouse gases, the surface could be mild and oceanic. The system is over 5 billion years old, older than our Sun, giving life plenty of time to arise and evolve. On Earth, complex life took billions of years. LHS 1140b has had even longer. If life began there, it's had a huge head start. The possibility of ancient, stable oceans is scientifically plausible. It's a world with all the right ingredients for a long, complex story. What does it take for life to emerge? First, liquid water, a universal solvent for life's chemistry. LHS 1140b sits in its star's habitable zone, making liquid water possible. Next, energy. Life on Earth uses sunlight, but LHS 1140b's red dwarf emits mostly infrared. Any plant life there might be deep red or black to absorb more energy, or life could thrive around volcanic vents, as on Earth's ocean floors. The right chemical building blocks, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, are likely present, forged in stars and scattered across the cosmos. The real question, have these elements combined in the right way to spark life? Time and stability are also crucial. LHS 1140b's old quiet star and massive stable planet provide billions of years for evolution. Its peaceful cosmic history gives life a long runway to develop. All the ingredients are there, the only unknown is whether life ever began. LHS 1140b is a cosmic laboratory, waiting for us to discover its secrets. The potential is staggering. But what about the challenges? Let's look at the hurdles life would face on a super-Earth. LHS 1140b's greatest challenge is its gravity, up to 3 times stronger than Earth's. Every movement would feel like carrying 2 extra people on your back. Life here would need to be built for strength. Trees would be short and sturdy, animals squat and powerful. Flight would be nearly impossible. The energy required would be immense. The landscape would be flattened. No towering mountains, just rolling plains and deep oceans. The atmosphere would be denser, with crushing pressure at the surface. Breathing might require entirely different biology. The oceans, however, could be a sanctuary. Water offsets gravity's effects, allowing life to thrive more easily. Marine life on LHS 1140b could be diverse and resilient, hidden beneath the waves. If the planet is a water world, its true story may be unfolding deep in its global ocean. Life would adapt in ways we can only imagine. The challenges are immense, but so is the potential for discovery. With such a fascinating world nearby, can we visit? Not yet. LHS 1140b is 49 light-years away. Light itself takes 49 years to get there. Our fastest spacecraft would take over 76,000 years to make the journey. Even with future propulsion breakthroughs, the trip would span many human lifetimes. Concepts like fusion rockets or solar sails are still theoretical. Communication would be slow, a 98-year round trip for a radio signal. Any mission would need to be fully autonomous. For now, our exploration must rely on telescopes and remote sensing. The dream of visiting remains distant, but our curiosity is undimmed. If we can't go, how do we learn about LHS 1140b? By studying its light. The James Webb Space Telescope, JWST, is our most powerful tool, designed to study exoplanets in infrared. JWST is already observing LHS 1140b, analyzing its atmosphere during transits. By examining which wavelengths are absorbed, we can identify gases like water vapor, methane, and carbon dioxide. The ultimate goal: finding biosignatures, gases like oxygen and methane together, which could indicate life. Such a discovery would be monumental, transforming our search from if to what kind. Even larger telescopes are coming, like the Extremely Large Telescope and Giant Magellan Telescope. These will let us analyze atmospheres and maybe even directly image exoplanets. We're living in a golden age of exoplanet exploration. LHS 1140b is at the frontier of this search. We stand at a turning point in our cosmic story. For millennia we've wondered if we're alone. Now we have the tools to seek answers. LHS 1140b is more than a data point. It's a symbol of our curiosity and drive to explore. It challenges us to imagine life under different suns, shaped by different forces. If we find life, it will be the most profound discovery in human history, reshaping our understanding of the universe. If we find nothing, that too is meaningful, reminding us how precious life on Earth is. Either way, we learn something fundamental about our place in the cosmos. The search continues, with every new telescope and every new world. The story of LHS 1140b is just beginning, and you're here to witness it. What do you think? Is there life waiting to be found on worlds like this? The universe is vast and the possibilities are infinite. We may never have all the answers, but we will keep looking.